Yeah, good morning. We'll have some today. We'll discuss some points related to lean tools. Yeah, we will discuss about how does the tools helps. Okay. Okay. We'll discuss about how that lean tools are going to help in improving productivity. Lean is the set of tools that assist in the identification and elimination of waste. Okay. They have given a term called MUDA for waste. Already told in the last class. So there were seven wastes, and also told about one waste, or say extra waste. Extra means, of course, a new waste identified, intellectual waste. So here I'm talking about the different set of tools that helps in identification of waste and also elimination of waste. By identification of waste and eliminating waste, what is the help we are going to get? It certainly helps in reducing the cost. Okay, no wastage, no extra cost. So we can reduce the cost. Second, improving the quality. So I told already there is do right at first time. That is without having any defectives or wastage. So going with the zero defect, nothing but improving the quality and saving time. So when there is no rework, when everything done at the first instance only, then of course you can save time also. Increasing efficiency. Yeah, yes, we are not going to do any extra additional work and all. Of course, the efficiency can be improved. Nothing but you can say performance can be improved. Efficiency, increasing the efficiency. Establishing flow in a process. Okay, there will be a continuous flow, no interruption in between. The raw material in and process, WIP moves to different workstations, and then in turn finished and quad checking and dispatch. So there won't be any interruptions. So we can say that there will be a continuous flow, establishing flow in the process, no interruptions. Next, enforce consistency. Okay, so there is nothing called. There are some quality defective parts may may coming out of that another thing to say like that. So we can say that there will be consistency in quality, enforce consistency of production as well as quality, reducing lead time. Okay, so by differentiating value added time and value added activities and non value added activities, by removing all non value added activities, we can reduce lead time also. Eliminating bottlenecks. Okay, so won't be any bottlenecks. Normally, bottlenecks are going to interrupt the production loss. Bottlenecks. Next, improves the visibility. Okay, so transparency in manufacturing. So those things are the advantages of using lean by eliminating waste and identifying waste. Okay, reducing the cost, improving quality, saving time, increasing efficiency, establishing flow in the process, enforce consistency, reducing lead time, eliminating bottlenecks, improves visibility. See, these are the advantages. We can say that Moda, that's what by help of lean. Okay, so what are the common lean tools? Okay, so they are the common tools. That is 5S. I'll let you know later. 5S and continuous flow, Heijunka, also called as level scheduling, Jidoka, automation, and automation. Both are there here. Just in time, Kaizen, nothing but the continuous implementer, Pokayok, mistake proofing, and the value stream mapping, PSM. So these are the various tools. I think your syllabus is mainly focusing on value stream mapping, and of course, a few chapters are dealing with all these common tools used as lean tools like 5S, Izinka, Jidoka, just-in-time, Kaizen, Pokayok, and all. So we'll highlight what are these tools. Okay, tools. 5S. I don't know, it's not coming. Yeah, so there are so many things are there here. That is, oh sorry, we can't. Along with the 5S, Izinka, Jidoka, and all. So there are some other tools also there. Along with after value stream mapping, you will have one more thing called as KPI. That is a key performance indicator, visual management, and Kanban. So they are the various tools. Okay. Yeah, now 5S. Okay, so here I don't know what's happening here. Could able to show only 3S out of 5S on screen. Anyway, I'll let you know. So 1S, of course, I'm talking about lean manufacturing tools. One is 5S. So one, sustain, that is regularly follow the standards, and sort, eliminate what is not needed, and set to order, organize what is needed, and two more S, that is standardize the best practice, and shine, clean and organize the work area. So they are 5S. Okay, 5S. That is 5S. One is sustain, sort, set to order, and the standardize and the shine. Okay, so these are the 5 tools. Next, how does 5S help in improving the performance or eliminating waste? Fire does, it helps in saving time. Saves time in looking for the items or tools. Okay. In improve workplace condition, that is clean, provide a spacious work center, and it helps in increasing safety. Helps in increasing productivity. Unnecessary items and dirt get in the way of employees and negatively impact productivity. So it helps in increasing productivity. Helps in helps in eliminating other waste. That is waste of motion, waste of transportation, and waste of waiting. So these can be eliminated using 5S. Okay, so all the how does 5S helps in improving performance? Helps in saving time, improves workplace condition, increasing the productivity, and also eliminating other waste like motion waste, transport waste, and waiting. So next, one more tool in Lean after 5S, it is continuous flow. You can see here, continuous flow. I told you already that is providing the smooth flow processing. Okay, smooth flow processing. So you have, say, for example, process A, process B, process C, and defect is detected and the countermeasures are taken immediately. Suppose if any process has got any defects, so immediately detected, and of course, nothing but and countermeasured, measures are taken immediately, so that there won't be any interruption in the process. There will be a smooth flow processing. Okay, this second tool in Lean is called as a continuous flow. That is basically the idea, the objective is to provide smooth flow processing. Our work in process smoothly flows through production life cycle with the minimal buffers between steps of the manufacturing process. So I told that is when the raw material enters in, when is when start processing, when going across various workstations. So there chance of there may be having some sort of interruption in one of the workstation. So by countermeasuring the any thing happened in the one of the workstation, correct it and pass that work WIP to next workstation. The idea is to have that smooth flow, no interruption. Suppose if one workstation got interrupted, then that's going to affect the next workstation, and there will be a pile up of WIPs, and all the all the remaining operations also going to be delayed. Okay, so that's why there should be always smooth flow processing. So WIP is very important. WIP smoothly flows through production cycle with the minimal buffers. So no buffer in workstation between the steps of the manufacturing process. Means nothing is going to be stored during in the workstations. Okay, everything is flowing immediately. There will be a continuous process. Okay, how this continuous flow helps? Just like how does 5S also helping. So here, how does continuous flow help? Okay, so one is of course helps in establishing the flow. Establishing the flow. Okay, it's very important. I told that not to interrupt the flow between workstations or between work centers. So there should be a continuous flow of WIP. Once the processing starts, immediately it has to move continuously without have any interruption. Okay, so how this continuous flow is going to help? One is helps in establishing the flow, reduces batching, establishes process flow, minimizing waiting between steps, improves quality and reduces lead time. Of course, by having that smooth flow between workstations, you can reduce the batching. Okay, so you won't be anything like this batch is waiting for till why next batch internet. So nothing like batch are going to wait. So they try to reduce the batching, establishing the process flow, continuous flow, minimizing the waiting between steps. Okay, so minimizing the waiting time between the steps, improve the quality. Of course, normally when the flow is continuous, there won't be any quality issues. Everything goes smoothly, improves quality and reduces the lead time. So ultimately, when there is no interruption and one starts manufacturing, we end up with this thing. So that I'm not telling that only manufacturing. So I told that lean manufacturing is not restricted only for manufacturing. So it can be applicable to process industries and also service sectors. So, whether you're going to service sector or process industry and all, the process is not interrupted in between. So it should have always continuous flow. When there's a flow, when continuous flow, certainly there won't be any quality issues also comes in. Everything goes smoothly. Okay. So it's like delivering lecture. If everything going smoothly, continuously, there's nothing disturbs you, and there will be a continuity of flow of lecture also. Same thing. Okay. So here also, so improves quality, reduce lead time. Second, it helps in eliminating waste of inventory. So certainly, WI is also one of the inventory. So we can remove, we can eliminate the waste of inventory, waste of waiting. So when the inventory is not going to wait between sessions, we can eliminate that waiting time also, and the waste of transportation. So certainly, when you are not going, when the flow is going to be continuous, when you are not going to get it back for river canal, so we can avoid even transportation. So waste of transportation can be avoided here. So it is eliminating inventory waste, waiting waste as well as the waste of transportation. And in addition to that, continuous flow also going to help increasing the profit. Okay, so continuous flow in production cycle helps in increasing the production with the minimal waste, which in turn increases the profit. Certainly, when there is no waste, when there is no waste in terms of anything, either the inventory or transportation or movement or storage, anything, when there is no wastage, certainly the profit also increased. Okay, so it helps in increasing the profit. Continuous flow in production cycle helps in increasing the production with minimal waste, which in turn increases the profit. Okay, these are the advantages, or you can say that continuous flow is going to be useful in lean manufacturing. Next, Eisenhower. So one more important tool. Normally, when you refer any textbooks of lean manufacturing, when you discuss lean manufacturing, people have a common habit of giving this type of words. What is the Heisenka and all? Okay, so common words normally in the TPS or lean manufacturing. Common word. Okay, Eisenka. Nothing but you can say level scheduling. Eisenka means sequencing or smoothing of production. Okay, basically sequencing is one of the important aspects. Assignment and sequencing are important because a wrong sequencing that leads to so much of idle time for both man and machine. So if the machine become idle, unnecessarily wastage. The man must become idle, unnecessary wastage. So this proper sequencing and smoothing of production, okay, it's very important. So that reduces lots of time and all, okay, particular idle time of machine and all, right? So if idle time is more, certainly due date also getting affected. So if the due date is affected, certainly customers, loss of customers. So all these are related, okay. So even though when we say the customers are lost, it's not only because of the quality of product, but sometimes it's maybe because of delay in supplying also. If the things are not supplied in time, customer they go for substitutes. Okay, so losing customers. So it's very important. So proper sequencing, smoothing of production is very important. It's what called as Eisenka, level scheduling. Okay, normally manufacturing terms people use the word level scheduling. It's a long term. Okay, maybe during 1960s and all, when you start when we used to refer textbook by Baker, K.R. Baker, industry scheduling and all, that time all these terms are very known, okay, SPT rules, scheduling and all those things. But these Japan people, Japan concepts and all, when they started these TPS and all, they have given a different names or terms called Aizenka. Nothing but a level scheduling only. By multiplying the tasks and distributing them better, and by standardizing them by carefully studied smoothing, better use can be made of the working time available for creating value. Okay, the idea is to create value for the product. Okay, that is by doing all this, that is multiplying the tasks. Okay, more number of tasks can be taken, and distributing them better. Okay, sequencing them better. Okay, which job should be done on which machine, which worker is going to be. So proper assignment, scheduling should be done. Okay, along with the time. So these four very important: man, machine, time, and job. So these should be scheduled properly. That's what you can say level scheduling. So distributing them better, and by standardizing them by carefully studied smoothing. Okay, smoothing. So one should not be overloaded, one should not be less loaded, one worker should not be more loaded. So we need to have a smooth leveling is very important. Equal distribution of load is very important for effective utilization of man and machine. So standardizing them, by standardizing them, by carefully studied smoothing, better use can be made of the working time available for creating value. So it's very essential that the working time available, okay, should be effectively used. So not to make, say for example, machine availability is 8 hours in a shift, then that complete 8 hours should be used. Okay, so can't be like some time might have gone for so wrong scheduling and all. So there's going to be so much of time wastage. So you need to take care of those things. Available time should be used properly. So here, work is appropriately distributed and no individual has too much or no little work. I told the same thing. So in the level scheduling, to make sure that no machine or a man or a worker, the same term, worker should be either overloaded or no too little work. Okay, sometimes it happens. If the scheduling is not done properly, then chances of having more workload for one worker and less workload for some other and all. So make sure that the work is appropriately distributed and no individual has too much work. And that's what the advantage or the use of level scheduling, nothing but you can say it Aizenka. So Aizenka takes care of all these things. That is level scheduling, okay, smoothing of level production, okay, smoothing of production. That's Aizenka. It's a third tool of lean manufacturing. Yeah, you can see it. What happens if we're going to be a level production and unlevel production. You can say it unlevel production. You can say it. So you have a part in line and part B line is so free. Okay, nothing loaded. Whereas following process, you can see it one more overloaded and part C line khali, no work is assigned. So you can say here it is leveled production. You can say it right side. You can say it. So you have a part A line and part B line also given work, and following process of part C also given work. So you can see it. When there is an unlevel production, so these two workers are like see this work, like here he's surprising that these are only having got overloaded, and he kept idle, no work is given, and here you can say total idle. Okay, so this is basically it happens when they are not level in the production smoothing. Okay, how does this Aizenka help then? Okay, so I told about now level scheduling and what are disadvantages of is that not leveled properly. So now how this Aizenka help? It helps in monitoring and load balancing. Okay, helps in monitoring and load balancing. Okay, load balancing. I told very important that in scheduling, load balancing very important across the machines and the workers. So helps in monitoring and load balancing. Provides a performance dashboard to help monitor the work at all levels in real time. Okay. So providing the performance dashboard to help monitor the work at all levels in real time. So all levels should be loaded properly. Next, it helps in better utilization of resources. Okay, so I told very important, I think very important that all the resources should be effectively utilized. Like should not be like some resources are going to be kept idle, like factories, shop floor, machinery. So they have to be utilized maximum, has to be maximized by improving their use so that more is produced with the existing resources. So instead of going for buying new resources or adding new resources, so effective utilization of resource very important. Utilization of resource effectively. Okay, that's what that Heisenka all level scheduling helps in better utilization of resources. Okay, say even that space also limited. Okay, we can't expect that there going to be so much of space available for factory. With the limited space, they have to keep. That's what 5S always says that. Okay, so utilization of a factory, shop floor is very important. Keeping all the raw materials separately, WIP and finished good, okay, in a proper place. Machinery also effective utilization of machineries also. To maximize, it has to be maximized by improving their use so that more is produced with the existing resources. Helps in standardizing the work. Okay, standardizing work. Very important. They have to standardize the work. Okay, so to avoid leveling and unleveling. So to balance it, so they have to standardize. It helps in eliminating the different types of waste. It helps in standardizing the work. Okay, so by eliminating different types of waste, we can standardize. Okay, that's how this Heisenka helps in as a tool in lean manufacturing. Judoka, automation. Okay, so you heard of the term called automation and automation. So these two are the terms once again coined by Japanese only. Okay, so here you can say it, judoka. I told already in the one of the class, judoka. It is no defect product should go out of the organization. Okay, so basically enforcing zero defect, in fact, zero defect. So, say for example, here you have the manufacturing scenario. So, manufactured components are moving here. So now it has to go now. So they are going to say stop. And they say that if they found a defect, it should be stopped here. Okay, not to be moved. So, what is Judoka? Built-in quality at the source. It's a tool that provides machine and operators the ability to automatically stop the work if any abnormality occurs. So it's very important that so it's able to detect the abnormality in the process or in any of the activities in the manufacturing. Okay, so it immediately should stop. Okay, so that by knowingly or unknowingly the defective components should not go out of the organization. Okay, so it's a tool that provides machine and operators the ability to automatically stop the work if any abnormality occurs. Okay, it's not just like, for example, it's a built-in quality at the source. Probably I can give example as nowadays a majority of vehicles are going to keep some what do you call as when the vehicles are going to be signaling, signal, suppose they are keeping that 50 kilometers, 80 kilometers is the speed, safety speed. So once it crosses 80 and that red blink starts, and up to 100 kilometers, the red blink always starts. Once the driver starts exerting the speed for 100 and above, then it starts giving you are overspeeding and all. Start 120, they're going to give so much of noise, so that trying to avoid the speed. Okay. So I think normally for the public vehicles, they used to put the governors so that nobody should go beyond the speed. They fix some speed. 60, 80 kilometers only they have to run. Likewise. So here, Judoka same thing here. Automatically they detect the defects. So that by unknowing also, the defects do not go out of the organization. Okay. It's a built-in quality at the source. Judoka is based on don't accept defects. Okay, it's very important. Don't accept defects. Next, don't make defects. Okay, so very important. Accepting is okay. It's a quality checking. After quality, if they found that it was checked, found defective, and then rejection is there. Customers they won't accept it. That is after manufacturing. But during manufacturing, it enforces that don't make defects. Okay, do right at first time. I'm repeating this point here. So no defects during manufacturing. Don't make defects. Don't pass defects on. So remember here, not to pass the defects on. Even if one of the workstation, if they found that any defects in the material or any process, they should stop there only. So that they can unnecessarily they can avoid unnecessary processing at the next level. So this Judoka basically based on don't accept defect, don't make defect, and don't pass defects on. How this Judoka help? It eliminates waste of defect. I told this is the first important objective of lean is to reduction of waste. Okay, reduction of cost, nothing but cost and waste, right? So reduce waste, reduce cost also, improve profit. That's there. So how does Judoka help for the organization? It eliminates waste of defect. It eliminates waste of defect. It prevents defective products from passing to the next process, and hence helps in saving time and waste of raw material. Okay, so suppose for example, even in the beginning only, if we found that the raw material is defective, can't be processed, so not going to move for next station. Or suppose in the second stage, during processing also, if they found that so the material or the process itself is not going properly, then they stop there only. So that unnecessarily processing at next level can be stopped. So in turn they can reduce, they can save material, they can save time, they can save lot many things. Okay, so that's what the Judoka helps. Eliminating waste of defect. It prevents defective products from passing to the next process and helps in saving time and waste of raw material. It ensures client customer satisfaction. Okay, ultimately, of course, the customers are important. All these profit or profit and all, profit or anything, brand value or whatever things you want to say, all these are depends upon the customers only. Customers, that's what customers are king. Okay, so ensure their satisfaction is very important. So ensures customer satisfaction. That is by maintaining the quality of the product. Reduce labor cost. Workers can frequently monitor multiple workstations at a time. Okay, suppose if everything automated and if there is no quality issues, if there is no defects in the system in terms of tool or operation or machines or material, anything, a single person can operate multiple workstations because no much worker intervention is there. Okay, so you can reduce the workers also. I think probably you might have seen that in many of the automation centers, one worker is going to take multiple tasks and simultaneously he does. Okay, so we can say it reduce labor cost also. So workers can frequently monitor multiple workstations at a time. Reduce lead time, turnaround time. Okay, lead time also reduced. So certainly, okay. So all non-value added is going to be eliminated. So reduce lead time, and of course turnaround time also. No need to go back. Okay, no turnaround. So everything is going to be a smooth flow, continuous flow. So these are the help of Judoka. just in time. This one more important. So I'm repeating this one here, just in time, uh, zero inventory concept. So not to keep any inventory. So always go for just in time procure, process, dispatch. Okay, nothing to keep as inventory. Nothing to be stored in the warehouse. One start manufacture, produce and dispose. Okay. So we can say some sort of pull system. Okay, so pull system here. Customer is going to demand the product. So we can say it, production as per the customer demand. Customer is going to wait. Okay, not the product. So anything manufactured directly goes to customers. So nothing is going to wait here. So production as per the customer demand. And the production is done as per the customer's demand and not as per the production demand. So normally they do forecasting. They're going to project the demand. Okay, this may be the demand for the product for the coming year based on the history of sales or based upon some of the techniques, forecasting techniques. So they're going to forecast the demand for the next year. So sometimes that's not going to be, what do you call as, can't be like go as per their forecasting. So this, for example, during 1920, they might have projected some demand, more demand for the automobile sectors, maybe four-wheelers or two-wheelers during 2021. But of course, suddenly that COVID-19 has made these things to, like it's a reverse, like though they have production, no market. So these all suddenly that going to disturb their entire schedule, or they can't go as per the forecasted way. So, but just in time always says that the production is done as per the customer demand and not as per the demand projected. Okay. Okay. And relies on many lean tools such as continuous flow, continuous flow, such as continuous flow, Aizunka, Kanban, standard work. Okay, so just in time, it can't work as a tool. Okay, so Judoka and just in time two are the two pillars, but for these two pillars are got so many tools. So just in time, it can't work alone as a pillar. So it needs some of the tools to assist, like continuous flow, Heizunka, Kanban, and the standard work. So that's about just in time. Okay, how does the just in time help? Okay, effectively reducing the inventory control. As the production is done after receiving the customer order, inventory storage is not required. Hence, reduce the storage space. Okay, just in time, nothing but a zero inventory concept. The idea is not to store anything. Okay, nothing to be stored in the godown. There is no warehouse concept. Everything procured, processed, and sent. Okay, so it reduces storage space also. No, nothing to invest on warehouse. No need of extra storage space. Not only for the end product, but also even for the WIP also. Nothing is going to be stored in the various workstations. Okay, that's what. So it reduces the inventory level at all levels. So because production is done after receiving the customer order only, so inventory storage is not required and reduces the storage space. The first help of just in time. Second, it improves the cash flow. Okay, so because you don't have to buy in a bulk. Normally, traditionally, what they do is all the manufacturers they're going to buy raw materials in a bulk to take the advantage of discounts. Okay, when they're going to buy in a bulk, they can get more advantage and they can reduce transportation. Okay, but only to reduce transportation, only to take advantage of discount, cost discount, they're going to buy in a bulk. Ends up with lots of losses. Okay, loss of inventory. Maybe you have to go down or warehouse, or also unnecessary investment on raw materials, and even technology outdate immediately. So, if suppose your technology may change within no time, then the inventory and the pipeline should be cleared. So before going for a buy, so unnecessarily end up with manufacturing the old technical items only. So certainly they're going to affect the prosperity also. So that's why it's very important that not to keep any extra inventory. So this just-in-time helps in improving the cash flow. Same way, that's what like I said, less cash invested on inventory. So more liquid cash is available. Okay. So more advantage of just-time. Or you can say it help. You can say it. So regarding waste, okay, it helps in waste. Okay, waste of overproduction. Okay, when you are going to buy everything as per the customer request or customer demand, so the question of overproduction won't come only. No overproduction. Nothing is going to be produced extra because everything is going to be a full demand. Customer demands, customer requests. So that much only they manufacture. And waste of idle time. Okay. It's idle time. Okay. That's what I can say. No idle time here because continuously, because there is a demand, they won't stop any machines and all because when there is a demand, they're trying to satisfy the customer demand. So certainly any worker or a machine won't be stand idle because they have to start continuously processing. So waste of idle time and waste of inventory. You can eliminate waste of inventory also because no inventory, zero inventory, no wastage. So this how that just-in-time helps in eliminating overproduction and idle time as well as inventory also. Yeah, I'll take this in the next class, lecture, continuous input and all. So today I told about these aspects, just lean tools only, just to go through this. Yeah, I told about these things 5 years and continuous flow, how continuous flow is going to help. Next, Zinka and Jidoka Lastly, just in time. So these tools explained in this class. Next class I will go with the different tools.